Hi guys, Mrs. H here. So today we're going to be looking at models of an atom and how the evolution of our understanding of an atom and what an atom looks like. So we have some vocabulary here. Don't worry too much about the vocabulary. There won't be, I'm not going to be specifically asking you, what does this word mean? Some of them you should know already, some of them you don't. No big deal. So, this whole idea of an atom actually started with two Greek philosophers. We have Democritus and Copernicus in the 5th century. And these two guys actually, basically what they said was that an atom exists and that it's indivisible, that you can't divide an atom. The thing of it is they had no data to support this. They didn't do any experiments to support this understanding. They just had this idea with nothing really to back it up. And so, but this idea of an atom actually started in the 15th century with Democritus. And so our understanding that, yes, there is an atom and this idea of it being indivisible has changed, but this is when it started. The other thing to note is they also thought that the atom's characteristic and what it looked like was based on what it did. So, for example, water is slippery and smooth, so the atom was slippery and smooth. Where iron is held together and it's really a strong substance, so it must have locks and hooks to make it strong. And so each atom was different based on its properties it had. So Dalton was the really in the 1803 was the next scientist to really add to our understanding of an atom. And so what Dalton's theory, atomic theory, what an atom is, that all matter is made up of atoms, that comes from Dalton, right? What we also know is Dalton had actually an idea of what the atom looked like. And he said that these were very small and actually very hard spheres that, again, was indivisible, and that each element atom was identical. And so that still rings true, is that each atom of an element is the same, but the fact that it's a hard sphere is no longer a true concept. The only exception to his understanding that might be inaccurate would be the idea of an isotope. And he didn't have any idea of what a neutron is, which leads to our understanding of a neutron. So it makes sense that he didn't understand that as well, because we didn't know about that particle. So, Dalton's theory was that hydrogen mass was small, and so the hydrogen sphere would be small, as opposed to iron, which iron has more mass, so the sphere would be bigger. Both of them hard spheres, but the mass and the size that we would represent the sphere in would be based on their mass. This was really we were limited in our understanding, and it didn't really explain the nature of atoms themselves, and it didn't really explain their appearance. But again, what he did have accurate was that each element can be attributed to having similar atom structure. And the other thing that he did was he actually is the first one to start using symbols for each one of the elements. Then in 1897, J.J. Thomson, he actually elaborated on the atom and discovered the electron. This was proved that the atom is not necessarily indivisible like we had previously thought, and that atoms are actually made up of subatomic particles with this discovery of the electron. The other thing to note is that in his experiment with the rays and the plates of metal, and he used different plates of metal, that the electrons were actually floating and scattered throughout this sphere. So this has become what's known as the plum pudding theory, and that no matter what kind of metal plate he used, they all had this electron negative charge. And so if we look at the model, what he actually did was he used the idea of positive and negative charges, and that positive charges opposite charges attract, and negative and the same charges repel, and use that concept with cathodes. And so that's where we have this understanding come from. The other thing that he did determine was that these particles are actually much, much smaller than hydrogen, and that they are these really, really teeny tiny particles. And so if we look at an image of this plum model, we have this sphere that is all a positive charge, and then scattered within the sphere are these electrons scattered all the way through. So if you've ever had plum pudding and it has like raisins all scattered out through the plum pudding, the raisins being the electrons, or fruit cake, the fruit scattered throughout the cake being the sphere of the atom, and the fruit being the scattered parts. He did win the Nobel Peace Prize, or Nobel Peace Prize. Why am I speaking so inaccurately today? He did win the Nobel Prize in 1906 for this understanding that he developed in 2 years previous. Now, Thomas had a student, Rutherford, and Rutherford actually wanted to continue on with his studies and the understanding that this plum pudding model. So when he started to do his work, he was actually working with Thomas and he was an assistant with Thomas. So then he developed another experiment to actually prove more thoroughly that Thomas was right. Now, that's not what ended up happening, but that was his intention. And it was his professor that Rutherford was a student of Thomas. So what Rutherford actually did was, again, using the understanding that if I have this plum pudding model and I run particles through it, alpha particles, which is a charged particle, through the atom, that they should go straight through if the plum pudding model was accurate. Well, what ended up happening is when these charges moved through, some of them, yes, did move through, but some refracted and some of them reflected. So some of them bounced back and some of them curved. And we should not have seen that if the plum pudding model was true. And so we had to change our understanding of what the atom looked like as a result of this experiment. And so this is kind of what his experiment looked like in a model. So we have the alpha source. So we have a source of where the particles are coming from. And those particle beams are hit onto a gold foil. And what happened was the gold foil actually scattered the rays, and the particles were scattered. And that's not what we should have seen if it was in fact the plum pudding model. Okay, so our understanding of the atom and what it really looks like changed as a result of Rutherford's experiment. So he said that these were kind of tiny little solar systems with a very dense nucleus, and then the electrons moving around in a circular motion, just like a circular motion that we see in planets, with the sun being the nucleus. Well, the nucleus is that positive dense center, and then outside of it is the nucleus, are the electrons, and they're spinning around it. So this is what is called the nuclear model of an atom, and it actually is the first time that we really thought of as an atom as empty space. Before then, we didn't really think that an atom was all this empty space, but atoms really are mostly empty space with these electrons spinning through this empty space. So this is known as the nuclear model, as opposed to the plum pudding, which, remember before, it's this solid sphere with electrons scattered out. Now what we know is, based on his experiment, is a nuclear model, and so you've got the positive in the center and the negative on the outside, and it's basically empty space. So then in a few years later, only 2 years later, Bohr actually did some studies, and this is actually known as, used the idea of quantum theory to explain the arrangement of electrons. And so what he said is that these are actually moving in specific orbitals or in specific paths. So before, electrons were just in the space, kind of moving in a circular pattern, anywhere in this, just around the center, where Bohr actually said there's a very predictable pattern that these electrons are moving in. And we know exactly where they're moving and exactly where they're spinning. And that there's actually energy associated with these electrons that are moving. So the farther, the more energy you have, the more energy levels you have, the more electrons you have. And so he proposed that there is a predictable pattern and a predictable space of the likelihood of where the electrons are. And so this was Bohr. Now, following Bohr and his planetary model is actually, you're going to actually be making Bohr models. So next week, when we are looking at different models of an atom, you are actually going to make Bohr models. And so this is what we see in a Bohr model. So we see the center nucleus. This is where our protons and electrons are. And then we have these energy levels, and electrons are filled in within the different regions or within the different energy levels. And so we will take a look at this more closely in the coming week. Also, he noted that an electron can move in between the shells, or in between the energy levels, if they gain or lose energy, or a photon. So now we have Schrödinger, I can't say this 5 times fast, Schrödinger's quantum model. Sorry, I slaughter his name. It's a tongue twister for me. So he's the next one to propose a model. And again, they're building on each other. They're building on what we previously knew. So again, there's still the belief and there's still the understanding that the center of the atom is a positive, dense area. But now what's going around these electrons? What is it about these electrons? And so he actually said that within each energy level, that there is a orbital that these electrons are moving within, and that these electrons actually act more like waves than like a light wave, and behave like waves. And so that's where the quantum model comes from, is this understanding that electrons are more like waves and that they move within these orbitals inside each energy level. And so this was in 1926. So again, about 10, 15 years later, after Bohr developed his understanding of electrons and the energy associated with them. And so we go from, Dalton in 1803 early on, and this idea of a hard sphere. And it takes over 130 years for us to really develop this understanding of what an atom looks like. But the last 20 years, actually even more like 15 years, there's all this progress that happens pretty quickly with our understanding of an atom. So then our last one is Chadwick. Chadwick formed his prediction based on Rutherford's model. And so this prediction was based on the idea that there is only positively charged protons in the nucleus, and that it could be broken apart due to like the repulsion of positive charges, right? So a positive and a charge and a positive charge are going to repel each other. And so in order for an atom to maintain that or overcome that repulsion, that there has to be something else going on in there. And so Chadwick is the one that determined that there's actually neutrons in the center of the nucleus to compensate for those positive charges not constantly pushing and forcing away from each other, because these atoms, these protons wouldn't stay together with that repulsion. So that neutron had to be present in order for that to stop from happening. And so Chadwick allowed us to understand how the nucleus of an atom stays intact, and that it's not just protons in the center, but there's actually neutrons in the center as well. And so since then, we have even more understanding of atoms, and we've looked at things like quartz. And actually, quartz is even a smaller particle of a subatomic particle. And so as we get more technology and we do more experiments on atoms, our understanding of our atom evolves and changes over time as well. So if you have any questions, make sure you're reaching out to me. I hope you have a better understanding of the atom models and how they've changed. Bye, guys.